Today we are doing the final exam review for Chapter 8. Chapter 8 deals mainly with exponents, and then we have scientific notation at the end. So, on Chapter 8, the first questions that you will see say simplify the expression. And remember, this sentence right here is the exact instructions that you will see on your final exam. So what they want me to do is they want me to simplify it, okay? I'm not sure. I think that on these questions on your final exam review sheet, it says write the answer as a power, but I don't want you to do that. You'll see exactly what I want you to do here. Now, I'm very aware that you can plug this in your calculator, and your calculator will give you exactly what the answer is. But that is not what I want you to do. You have to show me the middle step. Then you can plug it in your calculator and give me the final answer. But before you do that, I want to know that you know, what do I do with these exponents right now? Who can remember what do I do with the exponents? Sydney? Exactly. When I have the same bases, I just add the exponents. So 2 plus 7 is 9. Now, this is that middle step I'm talking about. I have to see that middle step. If you do not show me that middle step, you will not receive full credit. Okay? Now you can plug 5 to the 9th power in your calculator, and what are you going to get? All right, we have 1,953,125. This is your final answer, okay? But again, I do have to see this step in order for you to receive full credit, because I need to know, you know, all right, I've got to add those exponents right there instead of just relying on your calculator. Okay, this next one right here. What do you think I need to do? Distributive property. And I'm just going to multiply my exponents together. My base stays the same, and that's going to become 9 to the what? 20th power. Again, I have to see that middle step. Now you can plug in 9 to the 20th power. Now, this is going to be a very large number. So large that your calculator cannot fit the whole thing. So what it does is when it gives you that large of a number, it goes ahead and puts it in scientific notation for you. That is fine. Your answer can be written in scientific notation when your calculator gives it to you like that. On the final exam, I did not give you one that's going to be that big, but for this review, we did. So somebody tell me, what does the calculator say? 1.221 5766 546. Only 1 2, okay? Sorry. And then times 10 to the 19th power. No, you cannot cut it off. It has to be like that because those are all important numbers. That's why they left them on there. Now, everything after the 6 is going to be a 0, so you don't have to worry about it. But until then, so it's times 10 to the 19th power. So that is your final answer there. Okay? So the next type of example we're going to do says rewrite the expression with positive exponents. That is the major key thing here, is that it has to have positive exponents. I can never have a variable or a number with a negative exponent, okay? So what I want to do is I've got to do something to my base in order to make that exponent positive. And who knows, who can remember what that is? Okay? You take the reciprocal of the base. Well, you say, but x is not a fraction. Reciprocal means I flip the fraction. Okay? Well, let's write x as a fraction first. X over 1. Then what's the reciprocal of x over 1? 1 over x. And what that does is it changes that exponent into a positive exponent. It's exactly what I want to do. Now, there's nothing I can do to simplify 1 over x to the 6th. I don't want to write x out 6 times. So this is my final answer. So look at this next problem right here. I have a to the negative 2 and b to the 5th. Which one of these has a negative exponent? A. So A is the only variable I've got to fix. B is just fine. I don't need to do anything to B. So how would I make a to the negative 2 have a positive exponent? Let's write it as a fraction first, and then I can take the reciprocal. The reciprocal is going to be 1 over a squared, and then I leave b just like it is, times b to the 5th. That's my final answer. Now, there's one other type of problem that I want to write down, because there is one like it on your review sheet. Okay, let's say if you have 3 times 3 to the negative 2. Okay? What has a negative exponent that needs to be fixed? The 3 to the negative 2. This 3 is just fine. So let's write it as a fraction so I can flip it. Then I'm going to get 3 times 1/3 squared. Then I simplify. I get 3 times 1 over 9. And then I multiply. 3 times 1 over 9 is 3 over 9. And I simplify to 1/3. And that is my final answer. Okay? That's how you do the one, I think it's number 11 on the final exam review sheet. Okay? You only have to change the number that has the negative exponent. Okay, so let's do the next example. Evaluate the expression. Write your answer in simplest form. Again, you have to do the exact same thing. Okay? We've got to show all of our work before I can plug it into my calculator. So, what would I do first?
You would, on the numerator, you would keep 3, and then just add to it.
Very good. Keep my base and add the exponents. Now, what can I do if I have the same bases and they're being divided? What can I do to the exponents? Subtract the exponents, exactly. So I keep my base. What's 6 minus 5? 1. And then I simplify. What's 3 to the first power? 3. So this is my final answer. Again, you have to show all of these steps that I've given right here. I need to know you know the rules of the exponents. In order to get full credit, that's what you have to do. Okay. Next slide. They say, simplify the expression. The expression should have no negative exponents. All right? What do you think I'm going to do first? Distribute that 0 to everything. So, 5 times 0 is 0. And then I'm also going to have y to the 0. What is anything to the 0 power?
0.
Not 0. 1. Okay? Anything to the 0 power is 1. So my answer is 1. But you say, Ms. Freeberg, that's a letter. There's no way I can make it into a number. Yes. Anytime it's to the 0 power, your answer is 1. It does not matter if it's 1 million to the 0 power. It's 1. If it's z to the 0 power, it's 1. If it's a to the 0 power, it's 1. Anything that has an exponent of 0 is automatically 1. It does not matter if it is a number or a letter. All right, so our last example here is they're dealing with scientific notation. They want me to take a number from scientific notation and write it in decimal form. Then take a number in decimal form and write it to scientific notation. Now, if you remember, whenever we did scientific notation, we made a little chart. Whenever I go from scientific to decimal, okay, moving my decimal to the right means it's going to be a positive exponent. Moving my decimal to the left means it's a negative exponent. Remember that chart that we did? Okay? So let's do this. Look at what my exponent is. What is it? Is it positive or negative? Positive. So that means I need to move it 2 places to the right. So I go 2 places to the right, and my answer is 725. Now, The chart is exactly the opposite when you go from decimal to scientific. So from decimal to scientific, when I move to the right, it is a negative exponent. When I move to the left, it's a positive exponent. So it's exactly opposite. So which way do I need to move this decimal? To the right, because I've got to get that decimal but behind the first whole number, which is 3. So I'm going to have 3 times 10. How many places did I move it? 3. And I went to the right, so I know that's going to need to be a negative 3. Okay? And that is my final answer for the scientific notation.